Based on finite differences. So first method, derivatives using forward differences. So here formula, first derivative formula, second derivative formula, forward difference process. So this is the first derivative and second derivative. F dash of xk is equals to 1 by h into delta minus delta square by 2 plus delta cube by 3 minus delta power 5 by 5 up to so on into f of xk. So this is first derivative. So next, r is equals to 2. Second derivative formula, 1 by h square minus delta cube by 3 plus 11 by 12 delta power 4 minus so on into f of xk. So this is first derivative, second derivative in forward process. Forward derivative, forward process, derivatives using forward differences. So forward differences, two formulas. First one, first derivative f dash of x and second derivative f double dash of x. So this is first derivative. F dash of xk is equals to 1 by h. H is nothing but length of the interval. So length of the interval. So delta minus delta square by 2 plus delta cube by 3 into f of xk. So this is first derivative formula. Second derivative f double dash of xk is equal to 1 by h square delta square minus delta cube by 3 plus 11 by 12 delta power 4 minus so on into f of xk. So this is second derivative formula. So question, given the following table, find the values of x and f of x. Find f dash of 0.1 and f double dash of 0.1. So how to identify forward formula or backward formula in this total table? So middle of the middle value. So 0.5 up to okay. So your middle value is 0.3. We have to calculate 0.1. So 0.1 is nothing but front. So this is back. So forward pass. Forward we can calculate 0.1 in first of the table. So by using forward pass computations or forward difference formula. So next, in case we have to find out 0.4 or 0.45 or 0.5. In this case, so we can use backward difference formula, forward difference formula, backward difference formula. In case we have to find out 0.3 or 0.29, 0.3 is nothing but we can use central difference formula, central difference formula, central divide difference formula. So here we are using forward difference formula because starting of the table 0.1 is there. First derivative and second derivative. So first we can construct table, forward difference table. So forward difference table x values 0.1, 0.2, 0.3, 0.4, 0.5. So next f of x values 1.40 corresponding x value. Corresponding x value 1.56, 1.76 to 2.28. So these two values are given values. X sign f of x values. So next, so we can calculate delta, delta square, delta cube, delta power 4. So how to find out delta? So delta. So delta f of x is nothing but difference between these two, neglecting 1.56 minus 1.40, y2 minus y1 minus y naught. So this is x naught, y naught, x1, y1. So y1 minus y naught, 1.56 minus 1.40. So that is 0.16. So this is first derivative. First difference. So next, the difference between these two, 1.76 minus 1.56, 0.26. So next, difference between these two, 2 minus 1.76, 0.2. Here also same. 2.28 minus 2. So 0.28. So these are first first differences. Delta f of x. So next, delta square f of x. So same. Delta square f of x also same here. So 0.2 minus 0.16. The difference between these two. So delta square f 0.04. So next here 0.24 minus 0.2. So that is 0.04. Same here also 0.28 minus 0.24. So that is 0.04. So these are second difference, divide differences. So next, third differences. The difference between these two, 0. Here also, difference between these two, here 0. So next, 0 minus 0. So 0. So this is the forward difference table. So forward difference table. So in forward difference formula, so we can take so delta f. This is delta square. So this is delta cube, delta power 4 in formula. So delta f of x is nothing but this one, 0.16. So next, delta square f of x is nothing but 0.04. So delta cube is nothing but 0. Delta power 4 also 0. In forward process, in case backward process is nothing but 0.28, 0.04, 0, 0. So like, so this is backward process. So but here forward process, delta, so this is delta square, delta cube, delta power 4. So formula, this is the formula. First derivative. So f dash of x h, f dash of xk is nothing but xk is nothing but 0.1, 1 by h into delta minus delta square by 2 plus delta cube by 3 into f of xk. So formula, so f dash of 0.1. Xk is nothing but 0.1. 1 by h. H is nothing but difference between these. Difference between these values are equal 0.1, 0.1, 0.1, 0.1. This is called difference H 0.1. Delta. Delta is nothing but 0.16 minus delta square by 2. Delta square 0.04 by 2. So delta cube is 0. So we can calculate. So this is the f dash of 0.1 is 1.4. So this is first derivative. So next, second derivative formula. This is second derivative formula. So h square up to here, h square into delta square minus delta cube by 3 plus 11 by 12 delta power 4 minus so on. So this is delta, this is f double dash. Second derivative 1 by h square. So 1 by 0.1 whole square. Delta square. So delta square is nothing but 0.04. So delta square. Remaining all are zeros. So this is f double dash of 0.1. So this is second example. This is example 1. First derivative and second derivative of f at a point 0.1 is nothing but here. The next example 2. So given sine 45 is equals to 0.701, sine 50, sine 55 in degrees, and sine 60. Find cos 45. So we have to find out cos 45. So x value is nothing but 45, 50, 55, 60. 45, 50, 55, 60. So these are the x values. So f of x is nothing but sine 45 value. Sine 45 value 0.071. So 0.76, 0.81, 0.866. So these are f of x values. So these are x values. So these are f of x values. So next, so we can find delta, delta square, delta cube. So delta value. So difference between these two. here. Same. Difference between these two. So difference between these two. So these are the delta values. So next delta square values. So difference between these two. The difference between these two. X2 minus x1, y1 minus y2. So these are the differences. Here, difference between these two. This is delta cube. So forward difference table. So this is forward difference table. So next we can take. So this is delta, delta square. So this is delta cube. So delta, delta square, delta cube. So first derivative. So we have to find out cos 45. Differentiation of sin x is nothing but cos x. Differentiation of sin x is cos x is nothing but. So differentiation of f of x at 45 is nothing but we have to find out first derivative only. So differentiation of sin 45 is nothing but cos 45. So x is equals to 45. X value 45. Only we have to find out first derivative only. F dash of x. F dash of x is equals to cos 45. F dash of x value 45. So 1 by h delta minus delta square by 2 plus delta cube by 3. Formula f dash of xk is equals to 1 by h delta minus delta square by 2 plus delta cube by 3. So this is the formula. So f dash of 45 is equals to 1 by h. So 1 by h. So delta value 0.0589 minus delta square by 2. So this is delta square. So this is delta, delta
సార్
square,
హెచ్
delta
5
cube.
ఉంది కదా సార్?
హెచ్ వాల్యూ 5 ఇక్కడ. ఇది మిస్టేక్ రాశారమ్మా. హెచ్ వాల్యూ 5 ఇక్కడ. 5 రాయాలి.
ఓకే సార్.
హెచ్ ఇస్ ఈక్వల్స్ టు 5. మిస్టేక్ పడింది ఇక్కడ. 1 by హెచ్. యాక్చువల్ ఫార్ములాలో సో ఫార్ములా 1 by హెచ్. 1 by హెచ్. హెచ్ is nothing but difference between intervals. So delta minus delta square by 2 plus delta cube by 3. So this is the formula. So but here, so 1 by h. H is nothing but difference between these values. 45, 50 minus 45, 5. 55 minus 50, 5. 60 minus 55, 5. So here 5. 1 by 5 into delta 0.0589. So this is delta minus delta square. So 0. Minus 0.0057 by 2 plus delta cube by 3. So this is delta cube minus 0.0007 divided by 3. So calculate this value is 0.7047. So this is f dash of 45. That is nothing but cos 45 degrees. So here 5, not 0.87. So here 5. So backward difference. Derivatives using backward differences. So here are also same formulas, small changes in formula. So first derivative. So f dash of xk is equals to 1 by h is same, nabla plus nabla square by 2 plus nabla cube by 3. In previous formula, same 1 by h delta minus delta square by 2 plus delta cube by 3. So up to 3. So there is a small difference, alternative plus minus. So second order minus. So here all are plus. In backward difference formula, so 1 by h nabla plus nabla square by 2 plus nabla cube by 3 plus so on. In forward process 1 by h delta minus delta square by 2. So second alternative plus minus plus minus plus minus in forward process. But in backward process all are positive. Next f double dash of hk 1 by h square nabla square plus nabla cube plus 11 by 12 nabla power 4 plus 5 by 6 nabla power 6, nabla power 5. So these are the first order and second and first derivatives in backward pass computations or backward differences. The table given below gives the values of the tan x for 0.10 less than or is equals to x less than or is equals to 0.30. Calculate secant square 0.30. So we have to find out secant square 0.30. So secant square is nothing but the tan x differentiation secant square x. So tan x secant differentiation secant square x is nothing but we have to find out first derivative. Only first derivative is asking secant square of 0.30. So we have to find out first derivative f dash of x at a point 0.30. So here middle of the table here, this is the middle of the table. So 0.30 is nothing but here 0.30. So we can use backward difference table. So backward formula. So table, construction of table. So these are x values 0.1, 0.15, 0.20, 0.25, 0.30. So these all are x values. So next, f of x 0.1003, 0.15, 0.20, 0.2553, 0.3090. So these are x sign f of x values. Backward difference table. So this is nabla. Nabla of f of x. So nabla square, nabla cube, nabla power 4 f of x. So in backward and forward, both cases, difference table is same. Difference table is same. So here also same. The difference between these two here. So 0.1551 minus 0.1003. Here also same. Difference. Here also
సార్
same.
ఇది సెకండ్ ఆప్షన్ పైన వేరే ఉంది సార్. 1511 ఉంది పైన 1511 ఉంది సార్. ఎఫ్ ఆఫ్ ఎక్స్ లో ఉన్న చూడండి సార్ అది సెకండ్
51 0.1. ఓకే మిస్టేక్స్ ఉంటాయి నాన్న ప్రింటింగ్ మిస్టేక్ ఉన్నట్టున్నది.
అంటే
0.1
రెండిట్లో ఏది సార్ కరెక్ట్?
1511.
ఓకే సార్.
ఏం తీసుకున్నా మీకు ఆన్సర్ సేమ్ వస్తుంది, జస్ట్ డిజిట్స్ లో కదా. సో లాస్ట్ డిజిట్ సేమ్ డిఫరెంట్ వస్తుంది. టోటల్ చేంజ్ ఏం కాదు, న్యూమరికల్ లో మిస్టేక్స్ ఉంటాయి, ఎర్రర్స్ ఉంటాయి, ప్రాబ్లం ఏం కాదు. 0.1511 ఆర్ సో 11 అనుకుంటా. 11 తీసుకుంటే 88. ఇక్కడ 11 తీసుకోవాలి నేను, ఇక్కడ మిస్టేక్ చేశారు. 11 తీసుకుంటే 508 వస్తుంది. సో 0.51511 ఇక్కడ మిస్టేక్ పడింది. సో డిఫరెన్స్ బిట్వీన్ దీస్ టూ. సో డిఫరెన్స్ బిట్వీన్ దీస్ టూ హియర్ ఆల్సో difference between these two, difference between these two. So that is delta nabla f of x. Next, nabla square. Here also same formula. So difference table is same in backward or forward process computation. Both cases, difference table is same. So difference between these two, difference between these two. Up to continue this process, we are getting only single value. Single value. So this is the difference table. So next, in forward pass computations, in forward differences, we are taking so these values delta f of x, delta square f of x, and delta cube, delta power 4 in forward difference formulas, forward derivatives. So but here we are taking backward. So backward is nothing but so these values nabla f of x, nabla square f of x, nabla cube f of x, nabla power 4 f of x, nabla power 4 f of x. So these are the backward difference formulas. So nabla f of 0.3, 0.500540. Next, 0.0014 nabla square. Next, nabla power cube. So 0.0004. So next, nabla power 4, 0. 002. So these are values.
Sir,
Next.
sir, hello, sir. సార్ సెంట్రల్
చెప్పండి.
డిఫరెన్స్ ఉంటే ఎట్లా తీసుకోవాలి సార్ సెంట్రల్ డిఫరెన్స్ కి?
అది ఇంకా రాలేదు, మెథడ్ వచ్చినప్పుడు చెప్తాను. ఇంకా రాలేదు కదా.
ఓకే సార్.
నెక్స్ట్ అవే ఉన్నాయి. నెక్స్ట్ మెథడ్ ఏమన్నా డెరివేటివ్స్ యూజింగ్ సెంట్రల్ డిఫరెన్సెస్, దీని తర్వాత అవే ఉన్నాయి. సో నెక్స్ట్ ఫార్ములా f dash of 0.3 1 by h nabla plus nabla square by 2 plus nabla cube by 3 plus nabla power 4 by 4 formula. So this is first derivative formula. F dash of x power k is equals to 1 by h nabla plus nabla square by 2 plus nabla cube by 3 plus nabla power 4 by 4. So using this formula, 1 by h 1 by h is nothing but 0.05. So difference between intervals 0.05. So nabla plus nabla square by 2 plus nabla cube by 3 plus nabla power 4 by 4. So after calculating 1.0977. So this is f dash of 30. F dash of 30. So that is f dash of 30 is equals to secant square of 0.30. So that is 1.0977. So secant square is nothing but, so here is given tan. So differentiation of tan x is nothing but secant square x. So secant square of 0.30. So that is first derivative. Is there first derivative 0 point something 1.0977. So this is the secant square of 0.30. So next derivatives using central difference. So next topic. So derivatives using central differences. So formulas. First derivative f dash of xk is equals to 1 by h. 1 by h into mu into delta minus mu into delta square by mu into delta cube by 6 plus mu into delta power 5 by 30 minus mu into delta power 7 by 140. So this is the first derivative. Second derivative, f double dash of xk is equals to 1 by h square delta square minus delta power 4 by 12 plus delta power 6 by 90. So this is the first derivative and second derivative formula in central differences. Next, example 4. So is given x t values and f values. So we can find the acceleration at 0.3. T is equals to 0.3 seconds. So middle of the table is nothing but this is the middle of the table. So we are using central difference formula. Central difference formula is asking find the velocity. Question. Find the velocity and acceleration. So velocity is nothing but v is equals to dy by dx. Velocity is nothing but dy by dx. Acceleration a, it is denoted by a. Acceleration a is equals to d square y by dx square. So this is the velocity. V is equals to first derivative. Acceleration a is equals to d square y by dx square. We have to find out first derivative, second derivative at time interval t is equals to 0.3. So that is velocity and acceleration at the time interval 0.3. Next. So t value is 0.0, 0.1, 0.2, 0.3 up to 0.6. And capital T is equals to capital T formula t minus 0.3 by 0.1. So that is capital T is equals to T minus 0.3 by 0.1. So 0.3 is nothing but, so T value 0.3. So another T is nothing but 30 minus 1.3. 30 minus 1.3. So 30 corresponding to T is equal to 0, formulate the forward difference table and identify the central differences. So capital T is equals to T minus 0.3 by 0.1. So and T is equals to 0.1. So here, so T values 0, 0.1, 0.2, 0.3, 0.4 up to 0.6. So next F is equals to, so this is F values 30.13, 31, 32, 33, 33, 33 like this. So these are the F values. So here capital T is nothing but at which point, so this is at which point we have to calculate acceleration and velocity. So 0.3. So that is 0.3. At 0.3, capital T is equals to 0. 0.3 at capital T is equals to 0. Using this formula, 0.3 minus 0.3 by 0.1. So this is 0. So next, so T is equals to 0.2, 0.2 minus 0.3 by 0.1. So that is minus 1. So minus 2 here. Here also minus 3. 1, 2, 3 below. 1, 2, 3. Is clear? At which point we have to calculate the time interval or acceleration first derivative, that is 0. So upper side minus 1, minus 2, minus 3. And lower side 1, 2, 3. This is capital T. And F value is given in F. Next, delta F. So delta F is nothing but difference between these two. Same table. Here also same. Difference between these two. Difference between these two. Here. The table is same for forward, backward, central difference. In any case, difference between second value and first value. Here also same. Difference between these values. So this is the table up to delta power 6 into F. Next, first derivative formula. So derivative formula f dash of f of x. So 1 by h. We know h value and delta mu into delta minus mu into delta cube by 6 plus mu delta power 5 by 30 up to here only. So we have to find out mu into delta and also mu into delta cube and mu into delta power 6 values. We have to find out these values, these three values. Mu into delta, comma, mu into delta cube, mu into delta power 5. After substituting in this formula, so we are getting first derivative. So that is velocity. So mu into delta f of 0. So formula 1 by h into delta f of 0 plus delta f of minus 1. So delta f of 0, delta f of minus 1. So based on table. So this is delta x naught. So this is x minus 1, x minus 2, x minus 3. So in this case, so we can, so this is x2, x minus 1, x naught, x2, x1, x naught, x minus 1, x minus 2, x minus 3. So decrease downwards. So next case here, this is x1, x1, x naught, x minus 1, x minus 2, x minus 3. So next, this is x naught, x minus 1, x minus 2, x minus 3. So next, so this is x minus 1, x minus 2, x minus 3. So this is x2, x minus 2, x minus 1. So decreasing downwards. So this is x3. So this is x3 or t3. So this is t3, capital T3. So this is t2. So this is t1 or x1. So this is x naught. So decreasing downward direction. So here this is x naught, delta f of 0. So this is delta f of 0. So this is delta f of 1, delta minus f of minus 1. This is f of minus 2, f of minus 1, x1, f of 1, f of 2. So f of there is no f of 3. Next case, there is no f of 2. Next case, there is no f of 1. Next case, there is no f of 0. Like this. So based on above table, f of delta f of 0, 0.31 plus 0.77 divided by 2. So that is 0.54 is delta mu into delta. Next, mu into delta cube. So that is delta square values. Delta square of f of 0 plus delta square of f of minus 1. Delta square of f of 0 minus delta square of f of minus 1. So that is 0.015. So next, mu into delta power 5. So mu into delta power 5 is equals to 1 by 2 into delta power 4 into f of 0 plus delta power 5 into f of minus 1. So that is minus 0.15. So similarly, we can calculate delta square f of 0, delta power 4, f of 0. So these are used in second order derivative, f double dash. So next, substituting these values in formula, f dash of 0.3 is equals to 1 by h mu into delta. So mu into delta is nothing but 0.54 plus minus mu into delta cube by 6. So that is mu into delta cube by 6. So next, mu into delta power 5. So 1 by 30 into minus 0.152. So this is f dash of 0, that is velocity. So next, acceleration. Acceleration formula, second order derivative. Second order derivative, f double dash of xk is equals to 1 by h square delta square minus delta power 4 by 12 plus delta power 6 by 90 into f of xk. Acceleration, f double dash of 0.3 is equals to 1 by h square. So 1 by h square is nothing but 1.1 by f double dash of 0.3 is equals to 1 by 0.1 whole square. Next, delta square minus delta power 4 by 12 plus delta power 6 by 90 into. So this is the acceleration. A is equals to minus 45.6 centimeter per second square. So this is acceleration form.
ఏమైంది సార్ వెళ్ళిపోయిండా?
So this is acceleration, second order derivative. So next, methods based on interpolation formula. So like interpolation formula is nothing but Newton's forward formula and Newton's backward formula. So derivatives using Newton's forward difference interpolation formula. So here also first derivative and second derivative formula. First derivative formula. So this is first derivative f dash of x naught. F dash of x naught is equals to 1 by h delta f of x naught minus delta square of f of x naught by 2 plus delta cube of f of x naught by 3 minus delta power 4 f of x naught by 4. So this is Newton's forward first derivative formula. So next, second derivative formula 1 by h square delta square of f of x naught minus delta cube of f of x naught plus 11 by 12 delta power 4 of f of x naught. So this is second derivative formula. Example, for the following table, estimate f dash of 0 and f dash of 1.5. So f dash of 0 and f dash of 1.5 is given x values and f of x. Here h is equals to 1, then the forward difference table. So forward difference table 0, 1, 2, 3, x values. F of x values 1, 0, 1, 10. So 0 minus 1, minus 1. 1 minus 0, 1. So next 10 minus 1, 9. So 2 minus of minus 1. 1 minus of minus 1, 2. So next here also 9. So next 6. So this is the forward difference table. So here if delta f of x naught is equals to minus 1. So this is, so delta square f of x naught is 2. Delta cube of f of x naught is 6. So this value is delta f of x naught minus 1. Delta square f of x naught is 2. Delta cube f of x naught is equals to 6. So substitute in equation 19 is nothing but first order derivative formula. F of x is equals to, so we are getting polynomial. In this equation, so this one, first order derivative. So 1 by h into delta f of x naught minus delta square f of x naught by 2 plus delta cube f of x naught by 3 minus delta power 4 f of x naught by 4. So f dash of 0 is equals to directly 0. So substitute in that formula f dash of 0. So we are getting 0 value. So P is nothing but x minus x naught by h value. F dash of 1.5. So 3x square minus 4x. How to get this value is nothing but, so here in this formula, no need to calculate polynomial function. So direct substitute. So 1.5 value here in this formula. So 1 by h square, 1 by 1. So delta square f of x naught. So minus delta cube f of x naught plus 11 by 12 delta power 4 f of x naught. So this is forward difference. The next, Newton's backward difference interpolation formula. So Newton's backward difference interpolation formula. So these are two formulas. F dash of xk is equals to 1 by h nabla f of xn plus nabla square f of xn by 2 plus nabla cube f of xn by 3. This is first derivative. Next, second derivative, f double dash of xn is equals to 1 by h square nabla square of f of xn plus nabla cube of f of xn plus 11 by 12 delta nabla power 4 by xn. Here central differences also. Same formulas. So previous formulas, Newton's forward backward is Newton's forward formula is equals to starting forward formula, forward past computations formula. Backward difference formula is nothing but same. So Newton's interpolation backward formula is equals to same backward difference interpolation formula. Here central difference also same. So next, Lagrange's interpolation formula. So this is a very, very important one. So methods based on Lagrange interpolation formula. In previous methods, all methods are if the length of the interval is equal, is nothing but difference between any two intervals are equal. So but here 3 1 is 2, difference 2, 4 minus 3, difference 1, 6 minus 4, difference 2. So Lagrange's interpolation formula is used on only if the length of the interval is unequal length of the intervals. Is clear? In previous, all methods are length of the interval is equal. So, but here in Lagrange interpolation formula, length of the interval is unequal. In this case, we are using Lagrange's interpolation formula. Next. So given f of 1 is equals to minus 3, f of 3 is equals to 9, f of 4 is equals to 30, f of 6 is equals to 132. Estimate the values of f dash of 1, f dash of 2. First derivative and second derivative at 1, comma 2. So before calculating derivatives, so first we have to find out polynomial function after differentiate with respect to x. Now, so substitute x is equals to 1 and 2. So these are x naught, x1, x2, x3. That is f of x naught 1, x1 value 3, x2 4, x5 6, x3 6. So next, so these are y values: y naught 3, y1 9, y2 30, y3 132. So this is the x naught, x1, x2, x3, y naught, y1, y2, y3. Is clear? So next, how to write formula? So this is very simple. Lagrange's interpolation formula. So for starting with x, so we are, writing, so this one. 1 by 2 x square minus 4 y square plus 2 y square plus 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 4 y square plus So how to write formula x minus, so leaving x naught, we cannot consider x naught on numerator, x minus x1 into next value x minus x2 into x minus x3. So this is numerator. We are writing first term, that is x naught comma y naught, first term. So x minus x1. We are leaving, we are not consider x naught, x minus x1, x minus x2 into x minus x3 divided by. So in numerator, substitute x naught, writing on denominator. So that is x naught minus x1 into x naught minus x2 into x naught minus x3. So this is numerator and denominator. Is clear? So in numerator, x minus x1, x minus x2, x minus x3. So now substitute x naught on numerator, write down in denominator, x naught minus x1, denominator first term, x naught minus x2, denominator second term, x naught minus x3, denominator third term. In case x4 is there, x minus x4 in numerator and denominator x naught minus x4 into total term into y naught, the total term into y naught. So next, second term. So that is x1, writing x1. So we are not consider x1 in numerator. So starting with x naught, x minus x naught into x minus x2. We cannot consider x1 into x minus x3 divided by. So substitute x1 on numerator, x1 on numerator, write down in denominator, that is x1 minus x naught, first term, x1 minus x2, second term, x1 minus x3 is third term, into y1. So that is this value, this one, x minus x naught. X naught is nothing but 1. X minus x2, x minus 4, x minus x3, x minus 6. So in numerator, substitute x is equals to x1. So that is 3. 3 minus 1, 3 minus 4, 3 minus 6 into y1. So that is 9. So this is second term. So next, similarly, remaining two terms also. So this is x2. So we are not consider x2 in numerator, x minus x naught, x minus x1, x minus x3 divided by. So substitute x2 on numerator, write down in denominator, x2 minus x1, first term, x2 minus x1, second term, x2 minus x3, third term, this one, x minus x1, x naught, 1, x minus x2, x minus 3, next x minus x3, x minus 6. So put x is equals to 4 on numerator, 4 minus 1, write down in denominator, 4 minus 3, next 4 minus 6 into 30, corresponding by value. The last one, your last one, x minus x naught, numerator, x minus x1 into x minus x2 divided by, so we are leaving x3. So that is to substitute x3 and numerator, write down in denominator, x3 minus x naught, first term, x3 minus x1, second term, x3 minus x2, third term. So that is this one. X minus x1 is nothing but 1. X minus 3, x minus 4. Next, 6 minus 1, 6 minus 3, 6 minus 4 into corresponding y value, 132. To simplify this value, for simplifying this value, we are getting a polynomial equation. A polynomial equation. So that is the polynomial equation. minus 3x square minus 6x plus 5. So this is the polynomial equation. No. So this one minus 3x cube minus 3x square minus x cube minus 3x square plus 5x minus 6. So this is polynomial equation. He's asking first derivative f of 1 and f dash of 2. F dash of 1 and f dash of 2. So differentiate this one. X cube differentiation minus 3x square. X square differentiation minus 6x plus 5. Minus 6 is constant 0. To substitute x is equals to 1, x is equals to 2. So this is the f dash of 1, f dash of 2 in Lagrange's interpolation formula. Here also same, find f dash of 10 from the following table. So here, how to identify the given problem is Lagrange's interpolation formula or not. Here, so length of the interval 3, 5, 2. So next 5, 11. So difference is 6. Next, here also 16 difference. Next, 7. So each and every interval length is different. So we can use only Lagrange's interpolation formula. In previous all questions, length of the interval must be equal or same. In Lagrange's interpolation formula, unequal intervals. So this is Lagrange's interpolation formula. These are known in.
సార్ ఒకవేళ వాళ్ళు ఏదైనా నేమ్ ఇవ్వకుండా ఓన్లీ క్వశ్చన్ ఇచ్చి ఏదో దాంట్లోనైనా ఒక దాంట్లో చేయమంటే ఈక్వల్ గా ఉన్నా కూడా లెగ్రాంజ్ లో చేయొచ్చా సార్?
ఈక్వల్ అంటే లెగ్రాంజ్ లో చేస్తే కొట్టేస్తారు. ఆ ఫార్ములా ఎప్పుడు యూజ్ చేయాలంటే అన్ఈక్వల్ ఇంటర్వెల్స్ ఉన్నప్పుడు మాత్రమే యూజ్ చేయాలి. అదే చెప్తున్నాను కదా. ఇక్కడ చూడండి, ఈ క్వశ్చన్స్ లో ప్రతి ప్రీవియస్ క్వశ్చన్స్ లో మీరు ఐడెంటిఫై చేస్తే లెంత్ ఆఫ్ ది ఇంటర్వెల్ ఈక్వల్ ఉంటుంది. ఈక్వల్ అంటే మాత్రమే ప్రీవియస్ మెథడ్స్ లో ఫార్వర్డ్ అయితే ఫార్వర్డ్, బ్యాక్వర్డ్ అయితే బ్యాక్వర్డ్, సెంటర్ లో అయితే సెంట్రల్ చేయాలి. సో ఈక్వల్ లేకుంటే డైరెక్ట్ లెగ్రాంజెస్ ఇంటర్పోలేషన్ యూజ్ చేయాలి. ఈ ఫార్ములా లెగ్రాంజెస్ ఇంటర్పోలేషన్ యూజ్ చేయాలి ఈక్వల్ లేకుంటే. ఇఫ్ ద లెంత్ ఆఫ్ ది interval is unequal intervals, so we can use Lagrange's interpolation formula. Is clear? So this is the Lagrange's interpolation formula. This is chapter 8.
సార్ ఈ ఎర్రర్స్ గురించి అడుగుతారా సార్ ఎగ్జామ్స్ లో?
అవసరం లేదు, ఎర్రర్స్ అడిగారు.
ఓకే సార్, అవి కొంచెం కష్టంగా ఉన్నాయి సార్ నేర్చుకోవడానికి.
అవసరం లేదు నాన్న ఇక్కడికి.
ఓకే సార్.
ఎర్రర్స్ ఇన్ డెరివేటివ్ అవసరం లేదు, ఇక్కడ సరిపోతుంది. ఇలా ఇంతే. ఇంకా మాక్సిమం మినిమం ఫంక్షన్ ఆఫ్ టేబులేటెడ్ ఫంక్షన్స్ కూడా డైరెక్ట్ ఫార్వర్డ్ బ్యాక్వర్డ్ లో వస్తాయి. ఈజీగా ఉంటుంది. జస్ట్ ఫార్ములా ఉంటుంది, ఫార్వర్డ్ డిఫరెన్స్ టేబుల్, బ్యాక్వర్డ్ డిఫరెన్స్ టేబుల్. సో దిస్ ఇస్ డిఫరెన్షియేషన్ యూనిట్ 8. Next topic. Next unit 9. Next unit 9, integration 1. So in this method, in this unit, 5 methods are there, totally based on formula. Trapezoidal rule. The first one, trapezoidal rule. First method, trapezoidal rule. So this is the first method. So formula for trapezoidal rule. So very simple. 1 h by 2. So this is the formula for trapezoidal rule. H by 2. H by 2, first term plus last term. So y naught plus yn. First term plus last term plus 2 into remaining all terms. So that is y1 plus y2 up to yn minus 2. H by 2, first term. F of x naught is nothing but y naught. F of xn is nothing but yn. F of x1 y1. F of xn minus 1 is equals to yn minus 1. So that is h by 2 y naught plus yn. Y naught plus yn plus 2 into remaining terms. That is y1 plus y2 plus y3 plus y4 up to yn minus 1. So this is trapezoidal rule formula. So example 1, evaluate integration 0 to 6 dx by 1 plus x square using trapezoidal rule. So here h is equals to h formula, h is equals to b minus a by n. b minus a by n. So b is nothing but a comma b is nothing but upper limit and lower limit. A is lower limit, b is upper limit. So a is lower limit of integration, b is upper limit of integration. N is nothing but number of divisions. So here we are taking minimum number of divisions is 6. Minimum number of divisions is 6. So this is minimum. Is not given, we are taking n is equals to 6. Here f of x is equals to 1 by 1 plus x square. A is equals to 0. So that is lower integration. B is equals to 6. Upper integration. So taking n is equals to 6. Is not given number of intervals. So that's why we are taking minimum number of intervals is 6. So h is equals to b minus a by n. So 6 minus 6, 6 minus 0 by 6. That is equals to 1. Okay. So next, x naught 0. X naught is nothing but x naught or lower integration, lower boundary. X naught is equals to 0. So that is x1 is equals to x naught plus h. x2 is equals to x1 plus h. x3 is equals to x2 plus h. x4 is equals to x3 plus h. x5 is equals to x3 plus h. So these are the formulas for x1, x2, x3. So this is x naught. So we have to find out x1 is nothing but x naught plus h. H value 1. H is equals to b minus a by n. So adding plus 1. x1, 1. So next x2. x3 is nothing but x1 plus h. 1 plus 1, 2. So next x3. x3 is nothing but x2 plus h. So that is adding 1 to each and every previous value. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 1, 6. Up to x6. 0 to 6 are here interval a comma b. So starting interval 0 to ending interval 6. Up to find out starting 0 to 6th. Okay. So this is the interval 6 to 0. So next, so we can calculate corresponding y values. So corresponding y values is nothing but f of x naught. F of x naught is equals to, put x is equals to 0. F of 0 is f of x naught is equals to 1. So substitute x is equals 0. We are getting f of x naught 1. So next, x is equals to 1. X is equals to 1. We are getting f of x1. X is equals to f of x2. x is equals 3, f of x3, x is equals to 4, and here x4, f of x5, f of x6 up to f of x6. So by using calc, so 1 by 1 plus x square. So in this equation, put x is equal to 0. We are getting f of x naught. Put x is equals to 1. We are getting f of x1. X is equals to 2. We are getting f of x2. So this value. So next, x is equals to 3. We are getting f of x3. X is equals to 4. X4. X is equals to 5. So that is 1 by 1 plus 25. Next, x is equals to 6. So this is f of 6. So these are x0, x1, x3 up to x6 and corresponding f of x0, f of x1 up to f of x6 values. So next, applying trapezoidal rule. So applying trapezoidal rule, h by 2 f of x0 plus 2 into f of x1 plus up to f of x5 plus f of x6. So that is first term plus last term, f of x0 plus f of x6 plus 2 into remaining all terms, f of x1, x2, f of x3, x4 plus f of x5. So after simplification, 1.4108. H is nothing but length of the interval 1. So here h value 1 by 2. F of x0 value is there 1. F of x2 value, f of x3 up to f of x6, all values are there. So 1.4108. So therefore, integration a to b, that is integration 0 to 6 dx by 1 by 1 plus x square is equals to 1.4108. So this is based on by using trapezoidal rule. So but we can calculate directly. So directly is nothing but integration 1 by 1 plus x square is nothing but formula. So this is the direct integration. So integration 1 by 1 plus x square is equals to tan inverse of x formula. So tan inverse of x, so limits 0 to 6. So integration 1 by 1 plus x square is equals to tan inverse of x, direct integration. So limits 0 to 6. Tan inverse of 0 minus tan inverse of 6 minus tan inverse of 0. So we can calculate on calc. So we are getting 1.5446. 1.5446. So in trapezoidal rule, taking step length h. So we can is sometimes is asking direct integration and compare direct integration with trapezoidal rule. So in this case, so tan inverse of 6 minus tan inverse of 0. So we are getting some value. So that value minus 1.4108. So this is the error. Is clear? So in case is taking h is equals to 2. Maximum we are taking h is equals to 1. In rare case, h is equals to 2 and h is equals to 3. The next step, using trapezoidal rule to evaluate integration 0 to 7 f of x into dx. So x0, x1, x2, x3, x4, x5. So these are the x values, x7. So next, corresponding y values, y0, y1, y2, y3, y4, y5, y6. There is no solution for this one. So this is trapezoidal rule formula. So formula is nothing but h by 2 first term plus last term f of x naught plus f of xn plus 2 into remaining terms. So this is trapezoidal rule. So next class, Simpson's 1 by third rule and Simpson's 3 by 8th rule. So Simpson's 1 by third and Simpson's 3 by 8th rule. So these are so this is based on formulas only. These two methods also based on formulas. So Simpson's 1 by third formula. So this is the formula for Simpson's 1 by third rule. Simpson's 1 by third rule. Simpson's 1 by third rule. H by 3. H by 3, first term plus last term. First term plus last term. That is y naught plus yn. So y naught plus yn plus 4 into odd terms. Odd terms is nothing but f1, f3 up to fk minus 1, n minus 1. Odd terms f1, f3, f5, f7, f9. Odd terms plus 2 into even terms f2, f4, f0. Y0 is already there. So y1 here, y2. Next, y3 odd term, y4. That is f4, f6, f8 up to n minus 2. So this is the formula for Simpson's 1 by third rule. H by 3, first term plus last term, f0 plus f2n plus 4 into odd terms plus 2 into even terms, f2, f4 up to fn minus 1. So this is the Simpson's 3 by 1 by third rule. Next, Simpson's 3 by 8th rule. Simpson's 3 by 8th rule. So this is Simpson's 3 by 8th rule. So integration a to b f of x into dx 3h by 8. 3h by 8, first term plus last term, f0 plus fn. So plus 3 into remaining all terms. So that is 3 into f1 plus f2 plus f3, f4, f5, f6. That's all. So this is the Simpson's 3 by 8th rule formula. So next class, Simpson's 1 by third rule, Simpson's 3 by 8th rule, Wedel's rule, and that's all. There is no need. Up to here only. Wedel's rule. We will discuss on next class Simpson's 1 by third rule, Simpson's 3 by 8th rule, and Wedel's rule. So this is the integration one in unit 9. We will continue next class.
Okay, sir.